study this kinds of simulation lecture is to analyze and get some insight about the production system, because the most kinds of production system inherently has dependencies among each processes, and also each process have their own probabilistic variability, and such kinds of arrival rate or effective working time. Those kinds of time data is inherently have variability. Also, most kinds of production system present a complex behavior owing to these kinds of dependencies and probabilistic variability. And so the efficiency or some productivity, it can be degraded if the production system is not properly controlled or properly designed. One of the ways to control this complexity or complex system is to analyze the behavior of the production system by using any kinds of simulation. And this discrete event simulation is a very representative method that is belonging to comprehensive simulation method. So in this class, you will learn how to analyze a various type of production system by using the discrete event simulation method. And in this class, we are going to study we are going to use the SimPy, that is open source, and also the SimPy kernel can be used in Python development environment. And this is the overall schedule of our class. Today is the first week and introduction. Also today we will have this lecture, why simulation is needed and when simulation is needed. And from next week, each topics will be transferred. And actually, because owing to the COVID-19, for the time being, we will. I'm sorry. We will proceed its lecture by using these kinds of the online real-time lecture, or by using the movie or video that is recorded previously. And also we will have two examinations. We will have midterm examination at week 7. At this examination, you will have a test about the calculation with respect to the several queuing models. And the final examination at week 14, this examination is expected to have the practical test. It means that I will give you the problem, and all of you will have to prepare your own computer, and during the time of examination, you have to develop your own simulation code. That will be the final examination. Also, we will have the term project. So at week 15, we will have some presentation class, and it means the offline presentation. Okay, the COVID-19. So for the time being, the most lecture will be provided through video or these kinds of real-time remote meeting program. It means the Zoom, by use of Zoom, or we'll use Zoom. And for the further questions, please post your question on course summary in class Q&A. So as I have told you, there will be 2 times examination, midterm and final. And there will be several assignments and also 1 single term project. Assignments will be assigned personally to each student. And firstly, for the queuing model calculation by hand and also by coding by using the SymPy. And also there will be 4 assignments about discrete event simulation example. This 4 assignment will be provided to you during 4 weeks. Each week, I will teach you 1 example, and each example have the relevant the assignment. And 1 single group project will be given. It means the validation of the several kinds of queuing models. And the answers will be supplied with commercial discrete event software. The reason why use this commercial DES is to let you compare your own result with the validated commercial software. And also the practical DES modeling and simulation about shipbuilding process by use of the in-house code, the sim component, and the about 13 or 12 week, I will teach you what is this sim component and how to use this package. Okay, we are going to review where simulation is used. Actually, simulation modeling method is a technique, and it is one of a simulation technique. And in most industry or in most the research field, this kinds of computer simulation technique is becoming increasingly popular as time and cost-effective method. Actually, this is very similar with the computerized towing tank. Maybe all of you already know what is towing tank. We have a towing tank in building 41, but it's a very big and it is very difficult to access, and also in order to perform any kinds of the experiment in actual physical towing tank, the time is required. Much time is required. Also, the cost is very burdened to secure the scaled model and some preparation for the water and preparation for the making a wave. But if we can have the computerized towing tank, it means that the simulation model that can simulate the behavior of a towing tank in the computer, that digital towing tank can be very time and cost-effective method. And also, the comprehensive simulation modeling method is a technique for improving or investigating the process performance of the factory or the service systems or the army. So most systems, we call the systems, most target can be simulated. Also, by using the simulation modeling method, we can evaluate the performance of capital equipment before the actual investment. So simulation modeling method is being used already in most manufacturing field and including the service area. So what is simulation? What is simulation? The simulation can be defined as follows. All the procedures for creating a model by computing an actual physical system with an organized mathematical technique and analyzing this model experimentally in virtual environment. In here, virtual means the computer. So if we think about the fundamental of the simulation, like just a simple spreadsheet, such kinds of Excel sheet can be the one of the kinds of simulation. Mostly the simulation technique is being broadly used or adopted in first manufacturing field and service systems, also in the field of transportation system. In case of manufacturing systems, in case of the requirement for the analysis of machining operation or assembly operation in automotive factory or some shipbuilding at the shipyard, the assembly factory of a shipyard. Also, I cannot understand why it's sensitive. So the material handling method or material handling systems can be analyzed by using the simulation. Also, the warehousing. Warehousing means that some storing area. So these kinds of target can be categorized as manufacturing system. And with respect to service system, we can have example of hospitals or medical clinics or retail stores, the big market, and food or entertainment facilities. It means the restaurant or some playground. And also these three kinds of system is an actual physical system. But in these kinds of information system, it means that the very huge communication system also is one of the example of a service system. It means that the communication system, including the broadcasting or the communication, those kinds of system can be included in service system, and those kinds of system also can be analyzed or experimented by using the simulation. An airport or the shipping port and train and bus transportation. This kinds of system is the transportation system. Also, in manufacturing field, distribution and logistics is a kinds of transportation system. So let's see the actual example. This is a very typical video of the manufacturing system. You can see here the transporting the robot, industrial robot with 6 axes. And here you can see the connected conveyor system. Also, there is a moving the worker, means the humans. And each this violet box means the product. We call it part in discrete event simulation system. So this kinds of simulation is performed before construction of this factory. So before the construction, It means that during the design phase of the manufacturing factory, through this experiment with the descriptive and the simulation, the factory designer can predict the performance of the target factory. This is the example of the restaurant or the eating area of the office or building. So especially this kinds of restaurant simulation is repeatedly used in the design of worship, because the worship is a very restricted area and very the narrow of each area, and also the eating time is limited because of some strategy or the fighting operations. So through this simulation of the eating area and eating time, the warship or submarine designer can assign a required space and the sequence of the crew. It means that how many crew can have their eating lunch or dinner in this area. So it is a very important decision point in the naval field, warship or submarine. Is it right, Mr. O?
Yes.
Of this.
Yes. Yes, very important.
And also, this is the example of transportation. Actually, this transportation system is the simulation technique is very frequently used. You can see here the pedestrian. I mean, pedestrian means that the moving picker. You can see here as a particle, but each particle presents one single person. And also, along this road, you can see the moving cars or moving bus. So the designer of a city, when they design the road and some traffic systems, they need to experiment their design of the city by using this kinds of simulation. So let's go in detail, the more categorized area. The area of application of descriptive and simulation is, as we have mentioned, the manufacturing and semiconductor or construction, military, logistics, and also including business process that is not the physical ones, also the human systems. In other terms, it is called the ergonomic systems. So let's see each example. This is my, in my life cycle, this is the first model that I have developed at the your age, about 2003 and 4. And this is the factory that make one of a part that is belonging to automotive engine. And the factory is located in Kia. And when they develop their own the engine, they are going to make fully automated factory that can produce the gasoline engines. So at the time, the factory designer want to check how many facility is required to guarantee the target throughput. At the time, the target throughput is I remember the target throughput is about 200,000 the unit per year. So when we have tested the 3 facility in each cells, that model could not satisfy the design throughput. So we have added one more facility in each production cells. So we can told to the factory designer in order to secure the design the capacity of production systems, you have to design as 4 machines in each the production modules. So this is one of the kinds of manufacturing application. And also this is the project that I have conducted at 2007. And my customer was the Mobis at the time. And this factory was the first factory that was operated by Mobis. Before this factory, Mobis have had no their own factory. They just ordered to the subcontractor and they only managed the design and the productions by the relation with the subcontractors. But this is the first their own the factory. And this factory produced the ECU. Anybody know what is ECU? ECU means the engine control unit. And this engine control unit is the comprised as a circuit board. And on top of the circuit board, the many kinds of the chips have to be assembled. So this factory was aimed to almost fully automate to fabricate and assemble this ECU unit. And the purpose of simulation is very similar with the previous ones. Okay, this is not, it's not my project. It was Googled. And in case of construction industry, this kinds of descriptive and the simulation can be used. You can see the process of the construction along with the time advance. Actually, in my understanding, most construction industry is they are not using these kinds of simulation, but very recently the help with the 3D computer aided design, and these 3D CAD designed models, the architecture can have maximize the visualization effect by use of the DES simulation. Also, maybe my students have already seen this example. This is the World War III. And you can see here the anti-USA alliance, and the blue one means the anti-China alliance, and they are fighting on the globe. At this simulation, the final result shows the winner is the anti-China alliance, but nobody knows if the production capacity about any military equipment or the number of the warriors. So anyway, it is very interesting ones because all the information about the manning, the manpower, and some the production capacity of all the world, all the nations in the world. So very massive data is being input to this simulation, and through the complex interactions between by simulating these kinds of war, we can predict who is the final winner. Also, the progress, how this war could be advanced, could be the procedure with this kind of simulation. Okay, let's go to the example of logistics. We can see here the map of the USA, and maybe this kinds of simulation can be the logistic company, the Amazons or the, what is the big mart in USA? Do you know?
Walmart.
Walmart, okay. That kinds of company that kinds of company have to simulate the overall behavior of the logistic system. So the use of this kinds of simulation, this logistic company can decide where each warehouse have to be located, and also where have to the retailer or reseller can be located in order to maximize the profit or revenue. Also, this is the business process simulation. Okay. It's not animation. Anyway, you can see here the cash out, shoot out, or roll-ins, and you can see this scenario 1 and 2. It means current state and with auto profitability. In these kinds of simulation, present the actual visualization. Instead, the non-visual data or non-visual information is visualized, and the behavior of this non-visual element can be simulated by use of descriptive simulation. Okay, now let's investigate when simulation is needed and when simulation is not required. Okay, first, simulation is desperately needed when target system is very complex. It's very sure. Also, there can be several kinds of alternatives. It means that with respect to the complex system, and also by changing the input and model conditions, so through the simulation, if along these kinds of the different kinds of input and model conditions, through the simulation comes the bring out the different kinds of result with respect to each alternative. Also, result with the simulation can suggest improvement in the target system, the target investigating system. Reversely, if if through the simulation, although we have conducted a simulation, the output cannot be differentiated. At the time, the simulation is not the effective. Also, with respect to the process variables, the different value of each variable, how the variation of each variable affect to the performance of target system. In this case, the simulation can be useful. Also, pedagogical, it means the educational. It means that for the purpose of education, this kinds of class also included in this case. For example, when the first grade student in our department, and they have no experience of the shipyard or shipbuilding. In this case, any kinds of simulation that can present the process of shipbuilding, the simulation can be used for the education for the first timer students. And also, when new design or new policies have to be decided, the simulation can be used for the decision about the designs and any operating policies. And also, the simulation can be used for the verification of the analytic solutions. Actually, we will have this kinds of simulation as the assignment. In more detail, in detail, the queuing models. Queuing models can be firstly calculated by the analytic method. It means that by calculation of the formula, but in order to verify the result of analytic solutions, the discrete event simulation can be used to verify the result of the analytic calculations. Also, the requirements of machines. It means that how many machines are needed in order to satisfy the target, the productivity. This is the one example that I have shown you in manufacturing and semiconductor factory. Also, this is the very similar with educational purpose in company, and the person who have no experience of the relevant field, the simulation can be helpful for the understanding of the target industry. And in some cases, simulation is used just for the visual animation. And sometimes these kinds of animation can be very, very helpful for the understanding of what is being conducted. So also the complex modern system, it is very similar, the case of the number one complex system. Okay, now let's see when simulation is not appropriate. Everything is okay? No questions? Not too easy? Okay. Okay. Simulation is not appropriate for the problem that can be predicted or can be solved just by using common sense. It means that without the help of simulation or without any calculations, there exist many kinds of example that can be solved by just thinking, human thinking. Also, the problem that can be solved analytically. It means that kinds of the kinds of analytic solutions for the problem of the what do you call 자유낙하? Free fall? Is it right? We have to ask to Samuel. Samuel, do you know 자유낙하? You don't know? So I think that there is called free fall. If the problem is to the height of the free fall, that kinds of problem can be solved by using the analytic formula. It means that V0 cross and 1/2 cross by the gravitational, the constant, and times time and square. And so the problem that can be solved by use of analytic formula, the kinds of systems is not appropriate by simulation. And also, it is very similar with the analytic. It means that the case of the problem that is easier to perform direct experiments. And also, in terms of the economics, if the cost, those are required to make a model and perform a simulation in the computing environment, that cost, if the cost exceeds the expected savings that can be secured by use of a simulation. It means that if the cost is bigger than effect or revenue, and this is not appropriate in terms of economics. What are you eating, Mr. Zhou? Is it delicious? Is it okay? Okay. The fifth case is that if there is no data that is needed to make a model, that at this case, we cannot do anything, even though the simulation can be helpful for the analysis of target system. But if there is no data, we cannot make a model. Also, we cannot simulate the target systems. And this is the very practical case. It means that if the manager or our customer have unreasonable expectation, it means that if our customer wants too much, and also my customer wants the result very soon. In this case, there can be very big conflict between the customer and the service provider. In this case, the simulation can be very negative. Okay, now let's review what is advantages and disadvantages of simulation. About the advantages, the new operation can be explored without disrupting ongoing operation. And this is a very typical case of ShipYard. because shipyard is a very big mega systems, and the shipyard system is fully operated status. So if anyone who have a very good idea that can enhance the productivity of the shipbuilding, but it is not possible to experiment that idea in actual shipyard. In that case, these kinds of the computer simulation replace the physical experiment. And second advantage is the new situation can be tested without the physical resources. Very similar meanings of first ones. Also, a certain kinds of phenomenon can be tested. It means that if we are going to change the conditions or some input data in our systems, and at the times, we cannot predict the result that is coming from this variation of input and system status. So at the case, the simulation can be very helpful for the prediction of the future status and future outputs. Also, insight about variables and their internal interactions inside of the systems. Also, in case of the complex manufacturing systems or transportation system, or even including the logistics, the bottleneck point can be investigated. It means that can be found with the simulation. Also, and comprehensively, what if questions can be answered? And disadvantage also exists. Actually, discrete event simulation is not the broad purpose theory and method. It means that in order to use or in order to let you be the specialist of any kinds of simulation, the special training and education have to be followed. Also, simulation results may be difficult to interpret. Actually, simulation bring out the raw data along the advancement of the time series. So from this raw data of the result, the spatial techniques and spatial algorithm is required to make this raw data, to transfer this raw data into some meaningful insight. And also, this simulation method is a method that very time consuming, and also this method required very expensive. But very recently with the environment of open source science, this expensive disadvantage is being lowered. It is decreased. Instead, by using very cheap or even zero cost open source, the open source code, we can make our own model very the economic way. So this is one of the purpose of this class. Actually, this is the very exact same mention that is being already showed in the when simulation is not appropriate. So skip to the next one. Okay, It's time. Okay. This is the first day, so I'm going to end today's class at this point.